Hello, and welcome to Spamhouse's webinar, Strengthen Incident Investigation and Response with Passive DNS. My name's Sarah, and I'm delighted to have the pleasure of introducing you to Carol and Matt. Now, Carol's very much part of the very fabric of the Spamhouse project. Most of his time spent investigating how a bad actor's infrastructure operates, and being head of data, it will come as no surprise to any of you that he revels in reviewing any data, whatever it is, anything that helps provide context and obviously ultimately protection. On to Matt. Matt's probably one of the most passionate people I know when it comes to anti-abuse. Following years of working on an anti-abuse desk for a well-known hosting company, Matt's now Spamhouse's industry liaison, and he works together with the wider industry to make sure we keep the internet a safe place. Now, just before I hand over to Carol and Matt, I'd like to mention that we will be having a question and answer session at the end of this webinar. We've opened up the Zoom question and answer window now, so please feel free to pop your questions in there as and when you think of them. But we will be answering them at the end. And I'll be quiet now and hand over to Carol.
Excellent, thank you, Sarah. Before we start off, a couple of things that we'll cover today. I'll start with a quick DNS primer, just for the people who are not super familiar with DNS, explain a little bit about the basics of DNS and how we will use that in Passive DNS itself. Explain a little bit about how the Passive DNS infrastructure works, how we create the data, how the data is structured. And then we'll go through a bunch of use cases, which is the exciting part, where we will show how to use this kind of data and how you can enrich anything you're looking at with the knowledge that is inside the DNS system and that is captured in the Passive DNS system. So let's start with a DNS primer. Before there was DNS, on the internet, it worked a little bit different. There was a thing called the host file. Here's the header of a very old one. As you can see, the date is March 1985. It's almost as old as I am. This was the way in early internet that names, the name to IP mapping was done. There's a central file, and you could have the name that you had for your machine added to that. Obviously, this was great in the early days when everybody on the internet knew each other. Obviously, at some point, as the internet got bigger, this became a problem, and there were a whole bunch of issues with this approach. Not the least being, for example, collisions, because there was no delegated system. Basically, every name was unique and could only be used by one person. So as you can see here, there's a bunch of IP addresses with the names behind it. It also has the services that were running there. But this was the early internet phone book, so to speak. Now, to deal with some of the issues that came out of this, a solution must be found and had to be found, and some of the key things that needed to be solved were things like delegated administration, where you do not have to go to a central maintainer to have something added to the file. Please, no collision issues anymore, and it should be robust. And that goes two ways. It should be robust in updating, because obviously if you have a centralized sort of phone book, and if I get my version up to date, but somebody else doesn't, then maybe an addition that I have made will not be available to everyone. So an automatic updating system would be a great part of that. Also, consistency. Not everybody having the same data causes all sorts of problems with that. So enter DNS, the domain name system, and in a nutshell, it addresses a whole bunch of those things. And there are some great characteristics in DNS itself that we will, as you will see later, are sort of at the basis of what Passive DNS is. So DNS is a system with hierarchy. It has a distributed authority. The authority is also on distributed infrastructure, and outside of your own domain, there are basically no collisions. And maybe one of the best parts of it, since its introduction, it has turned out to be super future-proof. I mean, the DNS has managed to grow with the enormous growth of the internet itself, and it is still going strong, and it has scaled to what the internet is now, which is quite the achievement, if you ask me. So let's look at the DNS is basically a tree model. You start at the root, like with an actual tree. It starts at the root, although I flipped it here around so the root is at the top instead of at the bottom. Under the root, you have various, what is usually referred to as top-level domains, TLDs, that are delegated from the root down. There's, for example, I put com in here, NL, because I'm Dutch, and org, and there are many others that are all delegated from the root. Under one of these domains, you can have, or one of the TLDs, you can have a domain name. So for example, example.org. Under example would be .example.org or events.example.org, which can even have subdomains. And you can, if you want to, you can go quite far down with subdomains on subdomains on subdomains if you want. So this tree model, where every layer has a relationship to the things above it. Now, if you in a case where you resolve a name, when you want to map a name to an IP address, what happens is you traverse the tree. You start the root, and the root server will say, well, I don't know what about the full name that you want to resolve, for example, example.org, but I do know where .org is or where .com is, and maybe you should ask again there. So it delegates you to the next level. And for example, if we want to resolve example.org from the root, you will go to .org, and from .org, they will tell you what the name servers for example.org are, which will be able to answer you the questions for anything under the domain example.org. So in its very basic way, DNS is you have labels and you have content, and the DNS records. So I briefly mentioned name server records. In the DNS system, there's a whole bunch of different labels, different type of records that tell you something about what it is. It gives meaning about to the data, and it also there's an implied structure to the answer that comes from it. If you ask an A record, if you resolve an A record, you will get an IP back. If you resolve an NS record, you will get a name server label back. So a certain type of record always has a certain type of information in the key. And again, this structured approach is ideal for what we do with passive DNS, is where we take all this data and store it and analyze it and make it accessible. So I'll do a quick jump through a couple of common DNS records. An A record is basically something that maps a name to an IP address. Like this example here, if you resolve musashi.spamhaus.org, you get 2 IP addresses out of there. The top one is an IPv4, the second one is an IPv6 address. It can be only a v6, it can be a v4, it can be multiple. Yeah, lots of options possible. An A record always maps a name to an IP, which is basically the most common record in DNS, is the ability to map a name to an IP address. I mentioned an S record before. A domain needs to have a name server, and the name servers are specified in the NS records. So if you look at spamhaus.com, for example, you'll find that a couple of DNS records look like this. Hideyoshi.spamhaus.com, musashi.spamhaus.com are both name servers for spamhaus.com. So the moment you resolve anything under spamhaus.com, you will talk to those name servers. They will answer you the question of whatever you ask that's under the spamhaus.com domain name. Email basically works the same. When you want to send an email to somebody at the spamhaus.com domain name, the mail server will do an MX record DNS lookup, and as a result, it will get an answer for where the mail should be delivered. In this case, mail.spamtag.com, and the mail server will go there, try to contact that, and try to deliver the email. Then there's a text record, also quite common, and which basically allows you to publish any text in a DNS record. There's no formatting to a text record per se. You can put any sort of text in there. SPF records are quite common. Now, SPF records themselves are formatted, but that's not a feature of DNS. That's just, you know, the sort of the agreement that is in the SPF specification, but another common use for text records these days is to put all sorts of verification records keys in there, like the example there, Zoom verify code or DNS set keys or any sort of keys you can publish in a text record as well. So last one I'm gonna quickly talk about here. CNAME record is basically an alias of one name to another. So it allows you to make a name under your domain, for example, www, point to a name that is controlled by a different entity. So for whatever east there may be where somebody else can control where it should point to. In this case, this is a content delivery network where the www.spamhaus.com alias is pointed to a name that is controlled by the content delivery network. So, having said that, in a nutshell, that was the introduction to DNS. DNS, it has hierarchy, distributed authority. There's distributed infrastructure operated by all different parties. You can have no collisions outside of your own domain. The system turned out to be incredibly future-proof and very important to our next step, to passive DNS. All the data in DNS is basically structured. Just the type of record informs you about what kind of results to expect. So, having said that, let's go on to passive DNS. How does it work? This is sort of the normal flow of doing a DNS lookup. A client resolves a name, let's say www.spamhaus.com. It will usually have one or more resolvers configured by whatever the network is on. You connect to a network, it will probably give you one or more resolvers. So the client talks to the resolver and says, I need to go to spamhaus.com. What is the IP address for that? The resolvers will go onto the internet and talk to wherever the authorities are to get to that answer. So from the client, you go to the resolver talks to the authorities, answers come back, and finally, when the answer that you are trying to get to is received, the resolver will present that back to the client. Now, where does the passive DNS data come from? It's captured at the resolver. At the resolver, we capture the queries and the answers and a couple other bits of information, but most importantly, the query and the answer. So we capture what is asked and we capture what is the answer to that question. We do not capture who is asking it. There's obviously quite some privacy concerns with that. So that is data that is not even captured, let alone stored and processed. So that is basically it. That's where the data in passive DNS comes from. We look in resolvers, we capture what the questions are and what the answers that come back to that are. Once we have that data, there's a lot of duplicates in there. Obviously, very popular websites are being requested quite a lot by a lot of different people. So there's a lot of deduping that goes on, and we store what is not seen before, or we update whatever we already have. We index the key. So the question, what type of record was requested and what the answer was, and we keep the history. Now, once we do that, we start building a database that will basically show you over time what kind of questions have been asked to the DNS system by all the clients out there, by and this can be home devices, this can be mobile devices, this can be corporate servers, anything that uses resolvers that we capture data from. All those questions are being captured, and often a user might type in www.example.com, but maybe on that page there may be different names, or for example a CDN or an ad or an embedded image or anything like that. So usually just one action results in a whole bunch of different DNS names needing to be looked up, which will result in name servers needing to be looked up, and maybe text records and anything like that, and CNAMEs being done. So just loading a simple web page can create this sort of waterfall of DNS lookups that are being done, and as a result are being captured and being processed. So now that we have this data, this is basically the core of passive DNS. We store all these lookups, we store all the questions, we store the answers to them, and we keep them. And there's all sorts of interesting things going on. For example, popular websites, I may get a different IP when I look it up than if you do it, depending on where you are in the world. These all enrich the data that is there. So now that we have all this data there, then the next question comes: how can we use this? In our case, the Spamhaus passive DNS system, there are two ways to use the data. There's a web interface for manual investigations where you can just log in and use a web GUI to sort of go through the data, ask the questions, click on multiple outcomes, and as a result, sort of work your way through whatever you're seeing there. But that is not the only way. There's also a quite rich API that allows you to integrate it with either automation or existing tools where you maybe not want to leave the environment that you're working in, and you just want to use the data in passive DNS as an enrichment to what you're already doing, and bring the data into your current workflow, your current data set, and enrich what you're looking at. And that is where the API really shines. So what do you use passive DNS for? Well, I mean, to me, the possibilities are endless. I'm a little bit of a DNS nerd, so I get giddy just thinking about queries. And to me, there's basically anything where, I usually say to people, anything where you encounter an IP address or a host name, at that moment you need to think about passive DNS. With passive DNS, because the lookups that are stored, you can access them both ways. You can if you have an IP address, which normally is the answer to a question in DNS, but because we store the data and because it's indexed both ways, you can also say, okay, now I have this IP address. What other questions have been asked where this IP address came up as the answer? So it's basically sort of a reverse phone book. Instead of looking up, what's this guy's this name's phone number, you can also say, okay, I have the phone number. Now, what's the name that belongs to it? And that is one of the power cases of passive DNS. We have the outcome of a question. We have the answer. Now, what was the question? And that is really a key part of where passive DNS shines. At the same time, when you have the names, when you have host names, domain names that you can look, you can see where are they pointing now. Maybe somebody else saw them point somewhere else than what you did, or maybe they were days, weeks, years ago, they were somewhere else with, and that might be relevant information for what you're looking at. So any of these things, threat hunting, forensics, brand protection, reputation assessment, all these keywords that are mentioned here, these are all cases where passive DNS can be used. And I'm sure there are people who are able to say, well, I come up with something else, and yeah, passive DNS added something to it. So this is really just a good start. I'm sure there are other things you can do with it as well. So finally, when you have these things, people often ask, okay, well, how do we use it? What can I enrich with it that I already have? Well, these are just sort of the starting things. If you have resolver logs yourself, or if you have NetFlow data, if you have an IDS, any data that comes out of an IDS or a log file, these are all things where you can add the data from passive DNS into the workflow, into the investigations that you're doing, and add the data and create extra context around what you already have. And it's usually that extra context that will allow you to make decisions, will allow you to get an insight that you didn't have before. So that is basically the introduction to DNS, to passive DNS, and what better way to see the power of what passive DNS does than to actually look at some examples. And so that's what we're going to do now. We're going to start with some phishing and brand protection cases. And for that, I will hand it over to Matt.
Thank you very much, Karel. And yeah, I appreciate the the overlook of DNS. It's always good for me to be able to see things like that, and also just letting people understand a little bit more how passive works. So first thing that we're going to be looking at here is Enumerate Miscreant Infrastructure. So in this example, so registrar accounts get compromised. Now, this doesn't mean that the actual registrar gets compromised. It's the customers of the registrar get compromised, and the DNS of those domains that are hosted at the or that are maintained or managed by that registrar are changed by the miscreant. So the first thing that we look at here are two name server records. And you can see them right there, ns1, ns2.firstdomain.dnsserver.com. And we see that both of these name servers are pointing to this 31.ip as their A records. So how we found out that this was something that was off the beaten path, or something that people weren't doing, was there were sudden changes to a lot of accounts that were at this specific registrar. So we do a little bit more investigation on looking at those IP addresses of those name servers, the 31.ip, and we see that there are a bunch of other name server records on there. Now, what a lot of these miscreants do with this type of thing is what a lot of people will end up doing is blocking just the name server name. They don't go back and block the IP. Some people do, some people don't, but they're hedging their bets and being like, if I have so many NS records, I'm able to kind of hide or distribute my my network out. So the last thing that we look at here is these NS records have been identified as something that is bad. So we see that here are all of these domains that have no association with each other, that have been registered all over creation, and there's just no relation between them, and they're all pointing to this ns1.firstdnshoster.com. So it gives us this indication that, okay, we've already identified this NS record as something that is bad, and we see that any domain that's going to be pointing towards that is trying to do something that is going to be used for maliciousness on the internet. So you're able to not just see specific things like, I can only just look up this one domain. You're able to look up the NS record and anything else that's associated with it. So you're able to identify the whole network that is being seen via the passive data that you're looking at. So I'm not sure if Corel may have a little bit of more insight into this, because honestly, he's the data guy. He's the real expert. And let's see if he has anything else additional to say.
Yeah, because so what this actually tells us is that the domain that first came up with the first DNShoster.com name server was, it looked just like an incident, and by seeing all these other domains on that same name server, we can say, okay, there's clearly no relation between the domains itself, other than they have moved from their existing name server where they were on for quite a long time, and they suddenly all moved in a very short time towards this particular name server. And the fact that they all came there in a very short window of time, and that some of them moved back from this name server to their original name server not short after, told us that, okay, there's a problem on a larger scale going on than just one person who got their name, the domains changed. And some of them went back very quickly. These were, if you look at query volume, you can see, okay, these are a little bit more active. Some that are basically part domains, some of them were on these bad name servers for weeks. But by looking at the entire history of, in this case, the bad name server, and the history of the domains that moved to this bad name server, that starts to paint the entire picture of, okay, there's somebody at work trying to get the credentials from a registrar and stealing basically domains that exist and have a good reputation, moving them onto their own infrastructure to be abused. And whenever they go back, okay, at that time the damage has been done. But really having the history and having the overview of what else is there than just the ones that you've seen yourself allows you to paint the picture of the entire story.
Awesome. So so now we're going to go over to another example, and Carl's going to do this one. This is regarding brand protection.
Okay, so obviously when you have this people always think that this only is placed to the bigger names on the internet. Everybody knows that there's a lot of phishing going on for things like PayPal and certain banks, but there's all sorts of brand infringement being done, and it doesn't necessarily have to be phishing related. It can just be people that are trying to profit off a typo that a user makes on their keyboard by putting up ads, or that's sort of the most easy way of doing that. It's also not super malicious, depending on the ads that they put up, but they're often these names are based on sort of typos or very much lookalikes of the well-known names. So using the Passive DNS system, we can not just look for what name points to an IP or what IP has what names on it, but we can also search for things that look alike. So one of the things that our Passive DNS system allows you to do is to specify a fuzzy factor. So if you look for a certain string, you can start saying, okay, I also want to see answers that are just in 1 or 2 or 3 or whatever you specify, characters different from the string that I've put in. So I've used Netflix here, and as you can see, you will find domain names that are very much alike, but not entirely. And some of them are so close to the Netflix name itself. For example, the Netflix, the fourth one in the list, the O is next to the I on most keyboards. And so that has probably been registered not as a fish, because actually, if you look at the domain, it's pretty old. But it's a typo domain. But imagine if you own that domain and you put advertising up that is competitive to Netflix, and then Netflix itself, it's not the brand experience that people expect. People that go to such a domain name that make the typo, they get something they don't expect. So from Netflix point of view, there could be it's not the experience they want people to have. So there's a way for them to find out what kind of domains are out there. Some of them are obvious typos, some of them are a little bit different, some of them may be malicious, some of them may just be typo squatters, domain squatters who get extra domain names. But by using the fuzzy search, there's a way to find out what else is out there. This is done on just the domain names itself. Obviously, we can also do that on the host name part and start searching for brand names. And because it's not always in the domain name. If you look at the examples that I put up here, the top one, account update review, that sounds pretty fishy. Manager order, kind of managed purchasing. The second one is just random characters. So one of the ways that and these are actually all phishing examples. One of the ways that the people who do this get around sort of the reviewing that gets done by the registries and registrars is to sort of not put domain name, not put the brand name that they're trying to phish in the domain name itself, but they put it in the host name. And if you have these kind of things displayed on a mobile browser, there's usually the URL windows are not very large. And so it might not be noticed that it actually doesn't end in apple.com, but it ends in something completely different. So by putting the brand name in the host name, it completely evades any detection that might have been done at registry or registrar level. The last example, the snafu.ir one's a little bit different. What happened there is that snafu.ir is actually was a legit domain name, and they had their DNS infrastructure compromised. And the people who did that just added a phishing URL to that good domain name, and were able to use the existing good domain name, the existing good reputation of the domain name to tag a phishing host name onto that, point that to whatever server they control, and so by that use the good reputation of the domain snafu.ir to host a phishing page on, and probably improve deliverability of their phishing emails by a little bit. So the searches you can do for these kind of things do not necessarily have to be, you don't necessarily need to have the exact name. You don't necessarily need to be searching for domains. It can also be in host names. All this information gets stored in the Passive DNS system, and it is all searchable for the users, either through the web interface or the API. Since phishing is always on everybody's radar, and it's always one of the top things that comes up to when people ask this question, we're going to go a little bit deeper into some of the phishing examples, and for that I will take it back to Matt.
Thank you, Karel. So yeah, we're going to be talking about 5 phishing examples here, each a little bit different than the other one. So, this is actually looking at the actual interface that we have. Now, it's not an entire screenshot of the thing because, well, there's a lot of data that is put on the screen. So we're going to look at the actual search that's being done, and then we're going to look at the results that happen. So the first thing that we're looking at here is PostNL-service platform-nl.cc. So PostNL is the postal service in the Netherlands. And so we're looking for the past month of where this domain has been seen, what we've seen with it. So we do that search, and then we get these results. So we see that, could this be, is this a bad domain? Is there something wrong with it? It's at the name servers that it's at, that's a legitimate hosting company that's, I believe, Namecheap, that is being used as the name server for it. So one thing that we can do is we can look at the additional information of what else is on that A record. So what is on 185 dot, etc. So we'll do a search against that right there. So we do pretty much the same time frame to search for it, and this is called a reverse search. So you have the forward search, which looks at things like your domain names and whatnot, and then you can do the reverse search to look at things like A records and whatnot. So we go and we look at this 185. So we see that there's PostNL, and then there's Payconic that is also it's a payment app that is available throughout a few countries in Europe, and it's also pointed to this same IP address. So the possibilities of PostNL and Payconic being on the same IP is quite unlikely. But we want to do a little bit more information. We want to expand out what we're looking at. So what else you can do here is you can just say, all right, I see that this one IP has these 2 domains on it. Let's go and look at the entire /24. So we're looking at all 256 IPs that are under this CIDR range. And what happens when we look at this? Well, we see that there's actually more on here and more that is wrong with this range. So you're just going to be looking at the mouse here, but you see here's a platform Payconic, here's another Payconic domain, here's PostNL, here's Payconic again, here's PostNL, and there's just a lot of things on here that there's probably something wrong being done here. So you can be pretty confident that it's not just a problem with a single server. It is actually a problem that is happening within whoever this hosting provider is that's providing the data, or not the data, the hosting to these domains. And it wouldn't behoove you to just send a takedown request of a single IP being a bad server. This is something where you would have to take potentially multiple measures, where you could block the entire /24. You could send takedown notices to those domain wherever those domains were registered, and you have a couple of options there. But being able to expand out your knowledge and understanding that it's not just a single IP and the 2 domains that we had in the previous just looking at the one IP, it's actually a systemic problem of that whole range has just some problems on it. Now, do we know exactly what all of the problems are? No, but we can definitely make an educated decision based off of the data that we're seeing via Passive DNS. So it just gives you that power and that context to see, okay, we're peeling back more and more and digging deeper into the whole infrastructure and getting a better understanding. So, that's just one example. So the next thing that we're going to look at, and this is something that Corell's going to take a look at, and this is more or less around why history matters in passive DNS. Go ahead, Corell.
All right, so I got another fishy looking domain name here. It's actually a Dutch one, betaalverzoek-ideal.top. Ideal is a joint payment platform by all the Dutch banks. They wouldn't use a .top domain anyway, but that's what we have. So let's start with that. And if we search for that, then here we have. We see the name server that it was hosted on. We have the SOA record, and we now have two A records. So we have the 8.1 and we have the 49.1. And if you look at the dates, you can see that while it is on the 8.1 now, I mean, if we do a lookup right now, this is that's where it hosted right now. But having the history that exists in passive DNS right here, we now also know about this 49 IP that we if we just had our own live lookup, we wouldn't know about that. So we now have a little bit of extra information to go on. And so if we start with the 8, we can, let's see what else is on that 8 IP, and we find a whole bunch of other somewhat fishy looking domain names, and they seem to be targeting various different countries in Europe. There's a couple of ones that look Dutch. There's a DHL parcels -NL, which I can assure you is not the actual DHL. But there's also some stuff pointing to Belgium, and again PostNL shows up. So and basically everything we see on this IP is starting to look pretty shady. But remember that we still also have the other IP that we had, the 49 one. So we can expand our knowledge with that and find out what else is there to expand on our knowledge. So let's do that. We now search for the 49 IP, and we find even more. Some of these domains you're seeing here are the same as the one on the 8, but there are a couple of ones that are not there. So again, and I think part of the knowledge here, part of the interesting stuff we can learn about this is that it's not so much about what is on what we're looking at. It's also what is the history of the domains, and it allows us to find more domains together, and it allows us to get some information about the network that we're looking at as well. Because if you find a couple of bad domains on an IP where there are also lots of good domains, you would probably take a different defensive approach to that than if you find something that within a very short time frame, just looking at just a couple of days here, all we see on here is just bad domains, and at that point you can probably take a much more aggressive approach in dealing with that. So the context that is available around just the names and the results that you get can inform you quite a lot about what is going on in a network, what is going on with a domain name. And another good case of that is our third case, which is the one that Matt will do.
All right, thanks, Corell. So, we're looking at this one here, com-signin-fr.us. Is it bad? Is it not bad? Who knows? Let's use our passive to figure all of that out. So first thing that we look at here is we just take a look at what the domain looks like. We see that there's 2 NS records, and we see that there's a CNAME record. So we don't really have the ability to go and see what's on the website because there's no A record. We can't actually resolve to that website. Now, this is something that people do from time to time. They don't have their root domain as resolvable. They use what? Subdomains. So the beauty of passive is you can look at all of that stuff. So we're going to do a right match. So that's looking at everything that's on the right side of the domain. Or being able to look at anything that's on the other side of that right match. So we do this check, and we see suddenly apple.com. support.apple.com. So we understand that this is where miscreants are using that ability to add on additional records onto the subdomain to be able to use that domain in a way that that you may not be able to if you tried to register apple.com sign in or whatever with that thing. So they're just using this more of a generic type of domain name to be able to try to escape that. So there's also an additional thing to look at on here, and they, since there's no A records on this, but when you start looking at this, there's a bunch of CNAME records for that dom.iserver.space. So we're going to take an additional deeper look, and we're going to see what else is on there. And lo and behold, it's a bunch more Apple phishing stuff. So you're able to do that, dig deeper. Honestly, just to be able to pull all of this back and be able to understand a little bit more. And you usually don't see, this is highly out of the ordinary for somebody being able to be like, okay, we're just going to create all of these domains and we're going to have them CNAME over to this this dom.iserver.space, which that's highly unlikely for somebody to do consistently. So we're going to take a deeper look and look at iserverpro.su, which is what everything on here points to with this CNAME that was being used. And then we pull back a little bit more and we look at that thing again, and we see here's all of these IPs that are that the domains are actually pointing to. And it lets you understand that there's definitely something that, they're trying to be as sophisticated as possible to hide where all of these things are. Now, we could pull back and look at every single one of those IPs, but I don't want to be here for hours talking about this. But what you see when you look at these individual IPs is you see that that's actually where a lot of those domains are eventually resolving to, just hopping CNAME to CNAME and then going to finally resolve at that IP. So it just gives you that understanding and being able to pull all of this stuff back and get a greater understanding for how these miscreants are setting up their networks. So, just an interesting thing to look at. So now we're going to be going on to that fourth example. And if Corel had any input on that last example, you can go ahead and do it. But this next example, talking about a .tk domain, is all him.
Okay, so yeah, I'll quickly add to the last one, the fact that something seems to be changing network where it's hosted about every other day, and these IPs are completely unrelated to each other. It's not like it's a load balancing type of thing where you move through different infrastructure on one network. No, it just switches from network to network that has seemingly no relationship to each other. Again, informs you something about, is this legit or not? Most legit things do not hop around like that. The fact that it keeps moving and that it keeps changing is highly indicative of bad behavior, and that is something of the now that you have the history of the passive DNS database to help you out. You can see that context. You can see that it was moving before you first found it, and then it's still moving later when you maybe look at it again, and it tells you that probably bad things are going on there. So another example, we're looking at a .tk domain here, windstream-auth-update gateway net.tk, which is almost certainly a phishing thing directed at the regional ISP Windstream in, I believe it's US or Canada. And again, we found this domain name in a phishing message, and we look where it's hosted. And .tk domains, for those who are not aware, that it's a free TLD. Anyone can request any name that's available inside .tk for free. All you have to do is go through the actual effort of requesting the TLD, the domain itself. So whenever you find anything that ends in .tk or a couple of them like that, it's always interesting to think, okay, these are free domains, so somebody didn't want to spend any money to have a label exist in DNS. And also because they are free, there's really not that much cost and effort needed to get more than one name. So usually when there's one, there's more. The question is how many more. Again, Passive DNS can tell you that answer if we find that it points to this 143 IP. If we look on what else is there, by doing a reverse search for the 143 IP, we will find a whole bunch of other Windstream ones. As Windstream auth, update gateway net. There is a update info gateway net and a update gateway net.gq.ga. So you'll find a couple of other TLDs in there, and these four that are seen there are all part of that same free domain business model where anyone can request any name and it just gets published. So whenever you see one of those, that's often there are more, because in the again, the domains are free to create. So often miscreants take that opportunity to create a bunch more because they know that a lot of defense and blocking and takedowns are aimed at domain names. So a lot of remediation to prevent phishing from happening, to protect customers, is done on the DNS and domain name level. So having multiple names is beneficial to the bad guys. And especially if the names are free, it's obviously a very easy way of doing that. So last phishing case we'll do is one for Matt, and we'll take that one.
All right. Yes, thank you. So we're looking at copyrights for Instagram.com. Is this bad? Is it a brand issue, or is it a phishing issue? So we're going to take a look into this, and more or less we're looking at that month time frame again. So we take a look at here, and we see that it's at that 213 dot, and it's hosted at what is that, Keeper host. And that's a legitimate hoster out there, and they let's see what's on that IP. Let's see what else is on there. So we're going to do that search against it, and we take a look at it here, and we have 525 records. So what this kind of looks like is, it looks like it's a web hoster. So they have a bunch of domains on here. And one thing that I like to be able to do when I'm looking at a bunch of results, and since I do a lot of this manual lookup stuff, I'm not the guy who's writing this automated thing. I look up manual things, and then I go to our people that write the automation and say, look, I found this, this, and this, and they're able to write a pattern or a rule or whatever to be able to identify more. The thing that you can look at here right away is you can see that there is login-instagram.info, there's helpabout-center.com, instagramforsecurity.com. So it behooves us to take a bigger look at this. So the thing that I do next is I sort everything in ABC order. And I know I'm not going to show you everything because there's 525 domains. But looking at this, we see that, look at this, there's a bunch of copyright domains on here. So there's something that's not in place here. We still want to see if maybe this could still be a brand issue or not. But we're starting to lean now towards this being an actual challenge on this IP. So we're going to take a look down. We're scrolling down. So we see, look at this. There's forum-fbsupport.ml, forum Instagram Center, a bunch of other forum domains. So we're like, there's actually something bad here. And then we go down and we see help-center-twitter.com, and then help-instagramsupport.ml. So yeah, there must be somebody that has a bunch of these domains on here that may be a problem. And we'll take one more look at a couple more slides here. Instagram, a bunch of Instagram domains. And then the last thing that we look on here, and this just solidifies our case. This is instagrambusiness.com. That L, that's an L, not an I. So it's definitely somebody trying to use misspellings and whatnot to be able to convince people that it's Instagram. And that, gives us all we need to understand that there's actually an issue on here. Now, should we be blocking that entire IP? Should we list that as something that's an advisory, that there's bad stuff on it? No, because all the other stuff on here is a lot of this is .tr, which I can't remember the exact country code for. There you go, Turkey. So it's for Turkey. So, you know, that lets us understand that it's a legitimate web hoster. And if we ended up blocking this IP, we'd be blocking a bunch of legitimate domains. So you need to be able to go through your passive and be able to make those understandings and get that insight to say, okay, it's a domain problem, not a server and IP problem. So you list all of the domains, and if you can find a common link between them, you know, the more the better. But you know, it gives you that understanding that you can say, okay, I just need to block all the domains that are showing up as, you know, some type of Instagram thing on this IP, because it just gives you that more concise understanding of all of that. So, you know, that's what makes passive DNS so powerful. And also when you're able to do manual things and be able to sort by domain or by your record or by your IP or by the date, it helps you just see things a little bit easier and be able to go through it rather than just having to go through a list of 525 domains that are all over creation in the way that they're sorted. So with all that, we did have a bonus case, but unfortunately we're running a little bit short on time. So we're going to be going through some slides really fast. Just don't look, everybody close your eyes. And we're going to go and we're going to finish out here. And Karel's going to talk about some things about passive and how you can take some thoughts out of what we've been talking about today.
Thank you, Matt. And if you actually are interested in the bonus case that we didn't have time to show, by all means, reach out to us, because this is the stuff that I love to talk to people about, and I love to show you what kind of things you can do with that. Having said that, to me, the big thing about passive is that it allows you to see what other people have seen. When you find a bad host name, a bad domain, you can look for yourself, you know, you can resolve it. Maybe you have logs that say, okay, it pointed here, it points there. But by having this passive database, you can see what others have seen. You can have that joint view, that joint intelligence be accessible to help you figure out what you're looking at. And that is often you know, very enlightening, and it can be a time saver. And there's just enormous advantages to having that global view available. But that's not all. Often when you look at passive DNS, you will be able to find answers to questions of what, where, and when. Is what I'm looking at, is it bad? Is everything here bad? Was it always bad? Is it moving around? Has it moved around? Anything like that, the passive DNS data will be able to tell you. And then finally, by using the history in passive DNS, you may be able to find other things that you weren't aware of, which may indicate problems that you haven't seen yet. Often miscreants will get domain names before they use them. A domain name only works once you bought it, once it's been registered. And often they will show up in DNS before they're actually being used by malware, by compromises, by whatever bad thing you may be looking at. And by using the passive DNS data, you are able to find all these extra host names, all these extra domain names that you may not be aware of yet, and use that to your advantage in protecting your network, your customers, or whatever you're looking at. And with that, I believe it is question time.
Thank you, guys. Thank you very much. So we'll whisk through these questions. I've had a few coming in. So the first one being, do third-party companies, domain tools, Farsight, etc., Spamhaus, collect passive DNS from the same global resolvers, or does each company have a different passive DNS database?
I believe that as with any good threat data out there, there's always some overlap, and there's always something that nobody else has. So there's definitely value in getting more than one.
Excellent. So basically not the same in terms of everybody doesn't use the same global resolvers.
Yeah, obviously, you know, if the very popular websites you will find in every data set, you know, everybody will have the answer to what is the IP for www.google.com in there. But yeah, because everybody resolves that, but there may be other things that only certain people have. So.
Excellent, thank you. And just, I guess, leading on from that, or kind of expanding on that and going down to a slightly more basic level, you know, we've just been asked, where does the data that you're searching come from?
The data comes from our own investigations and our partner networks.
Thank you very much.
But it's all anonymized. So where it actually comes from, I mean, yeah, we know who our partners are, but we do not know who did the query. Whenever a query is done and it in the end gets logged and puts in Passive DNS, we do not know what initiated the query, if it was a user who typed in a website name, or if it was a machine that did a lookup, or if it's a piece of malware that did requested a particular name. We only know what the question was, what the answer was, and when it was asked.
Excellent, thank you. And one more quick question: how does this data integrate with other applications?
You want to do that, Sid?
Yes, wrestling with the mute button. So you know, we have an API available, and that API is an industry standard. So essentially, all you need to do is be able to hook into that API, and you can make the calls and whatnot. We have full documentation on that on our website, and maybe that's something if Sarah wants to include that, so somebody can look over the API if they are interested in that. They can do that. So essentially, you just hook into our API, and you're able to make those calls based off of the schema that we've put together, and that will integrate seamlessly with anything that supports industry standard API stuff.
That's great. Thanks for that, Matt. And we do have Grace, who's reached out to us, who would like the bonus malware slides. So we'll make sure they get to you somehow, some way, Grace. Absolutely. Any more questions for us? Going once, going twice. Well, all that's left for me to do is thank you all very much for joining us today. Feel free to go ahead and trial Passive DNS if you'd like to. You can visit our website, but otherwise, have a great day, whether it's your morning, afternoon, or evening. And Michael, yes, we'll make sure that you can get hold of the presentation slides. All right, many thanks, everyone. Goodbye.